Okay, folks, this is video number 1 for chapter number 1. So chapter 1 of the textbook, and as you should know by now from reading the syllabus, this is elementary statistics. This is elementary statistics is the name of the textbook, a step-by-step approach. Author is Mr. Blumen, and it's the 10th edition. Now, I'll mention this one more time. It was in the syllabus. If uh, if money is an issue and you want to just rent the book, that's fine. If you want to buy, or if somebody happens to have a 9th edition, the 9th edition is very similar. And if you are totally desperate and you need just a PDF version of the 9th edition, I can email you a link. It's on the web. Okay, so let's get started. This is chapter 1, the nature of probability and statistics. Okay, now I want you to know that it's worth your while to look at the book carefully. Don't just go by my lectures. So for example, and I just don't have the time to read everything to you, of course. I'm going to follow the book very carefully, but obviously I'm expecting you to do your own reading. At the beginning of each chapter, okay, he'll have an outline. So here's the outline. Talks about what to expect. Read this over. It's very useful for you to get an idea of what's happening and what's going to be expected in this book or in this chapter. So the first thing we're going to do is we're going to talk about the two types of statistics that we use. This descriptive and inferential. We'll see that in just a minute. We're going to talk about what in the world is a variable. What are variables and what kinds of data do we have? What types of data do we have? Then we'll talk a little bit about data collection and sampling techniques. Now, keep in mind that there's not people out there that get their PhD in these various topics. So there's a lot more to this than what we have in this book. This is an introductory textbook. So obviously we're not going to go into excruciating detail, but we'll have an idea of what it's all about. And it'll certainly make you a better critical thinker. The whole purpose of this class is to help you become a critical thinker. And you'll hear my rants as we go along in the other chapters. If you don't know how to do mathematics, if you don't know how to do statistics, you cannot be a critical thinker, because all you're doing is just expressing your opinion. And it's fine to have an opinion, and this is America. You're welcome to your own opinion. But if you want to be a critical thinker and really be able to analyze things, you must be able to do math. You must be able to do statistics, or you're just not going to be a credible commentator. Okay, so then we'll talk a little bit about experimental design. Now, in this first chapter here, you see this section 1.5, 1-5, computers and calculators. I don't do anything from the book about computers and calculators. My reasoning is that at this stage of your education, you need to do everything by hand so that you really understand what's going on. In addition, in my experience, these books that use the various computers and calculators sections, they're just advertisements really for a particular calculator, and it's just not worth it. There's plenty of websites that you can go to if you need a little bit of assistance with some of the drudgery. Now, there is a lot of drudgery in statistics. If you did everything by hand, you'd go nuts. My advice is always the same. Do a few problems. Do 3 or 4 problems by hand so you really get the hang of it. But then after that, you can use the websites, because it is just drudgery. But if you don't do it ever, you're not going to be able to really understand what's going on. Okay, so section 1.5 we're going to skip. Okay, so now we have all these different objectives. I urge you to read this, and then what you'll notice as you go along here, like let's say for example, objective number 1 and 2, as you go through the text, what will happen is when they talk about objective 1 and 2, boom, there it is. Here's objective number 1. So you can kind of correlate, or you can connect in the textbook the various objectives. That was number 1, here's number 2, and so forth. So the book is very, very well written. I urge you to read it. I think it's well worth your time. The other thing I want to recommend is at the beginning of each chapter, he'll have a little section here. He'll talk about statistics today, and he'll talk about What's the relevance? How can you see in your day-to-day life, how can you see where statistics is being used? Okay, he also always has a little introduction, and he'll talk about, where you've seen this in your day-to-day life. Again, I don't think it's worth your time for me to just sit here and read this to you, but it's certainly well worth your effort to read through this to get some idea of how important statistics can be. All right, so first thing we get to is a definition. This is typical of math books. They will give you definitions. In this book, typically he'll have a definition is in a green box. Okay, the green box is a definition. So here it is. Here's our definition of what statistics is. It's the science of conducting studies to collect data, organize the data, to summarize it, to analyze it, and then draw conclusions from data. Now, this is probably as good a time as any for me to go on a little bit of a sidetrack here and talk about how important it is for you to have examples in your mind. All of you folks have a different reason for being in this class. So a lot of you might be in the nursing class. Some of you may be in business class. Some of you may be scientific majors. You're going to major in physics or what have you. So there's all kinds of different reasons for people taking this class. It's very important, and I stress the word very important. I want to reemphasize this, very, very important that you have examples that make sense to you for all of these topics. The examples that the author gives are typically very simple-minded. They're examples that any of us can understand regardless of our background. The disadvantage of that is that sometimes people look at these examples and they say, oh my gosh, that's so boring or that's so simplistic, and I just am not interested in that. And I understand that. That's fine. So find your own example. As an example, if you are a nursing major, find examples either in the exercises or in the index or look online, however you want to do it. Find examples for each of these concepts that is important to you. So if you're a nursing student, or if you're pre-med, you want to go to medical school, you want to become a physician's assistant, or whatever your goal is in the medical world, there's so many examples of where the concepts that we're dealing with here are going to be important in the medical studies that you're going to have. And I'll try to point them out as I go along. When I was a very young man, I worked my way through college as a paramedic, so I do have a little bit of a medical background. So I'll try to throw some examples in there. At the present time, I'm an attorney, so there are not too many examples, but there are some examples that I can give you from the legal field. And before I did this, I was in the scientific world, worked on the missile program at Norton Air Force Base. So obviously we use math there all the time. Okay, so we talk here about the statistics as a science. Okay. Now we're going to use the word statistic later on, and there's going to be a distinction between statistics, a statistic. Give me 1 second here. Okay, I'm sorry, I had a little technical difficulty there. We're going to see later that we use this exact same word, statistic, we use it in a different way. What we're going to do is we're going to talk about something being either a statistic or being a parameter. So that's unfortunate, right? It's unfortunate that we use the same word to mean different things, but that's just the way it is. So you can tell from the context that if you're talking about the science itself, statistics is the science of conducting the studies and so forth and so on. It's a branch of mathematics that does these things, okay? All right, so I guess what I'm trying to get at here is then later on in section 3-1, you'll notice we use the exact same word. We say a statistic is a characteristic or measure obtained by using the data values from a sample, whereas a parameter is the same thing, a characteristic or measure where you get it's using all the data values from a specific population. For parameter goes with population, statistic goes with sample. That's how I remember it. Just by and alliteration. Statistics is for sample, parameter is for population. Okay, now we're not going to talk about this yet. I'm just using this as an example of how confusing it can be if you don't have the vocabulary down correctly. You've got to be careful on this vocabulary or you will be misled. Give me 1 second here. Am I making you dizzy by going so quickly through this? The screens here? Sorry about that. Okay, so here we are. We're still in section 1-1. Talks about why are we studying statistics? Why is this relevant? What's the importance of it? I'll let you read that yourself. It's very, very important, to know the motivation. And then in this chapter, the goals, we're going to talk about what are the branches, what do we mean by the word data, and how is data collected. Okay, now, let me just mention one more thing here. The word data is a little bit confusing. There's not very many words from the English language that come right from Latin, but here's one of them. Datum, D-A-T-U-M, is a single data point. If I measure Johnny's height, that is a datum, D-A-T-U-M, otherwise known as a data point. If I have two data points, if I have Johnny and Sylvia and Billy and Johnny and so forth, okay, those are called data. That's more than one data point. So if you use the terminology correctly, if all you have is one single measurement, it's improper to call that data. That is a datum. That's a single point. Okay. Okay, so let's move on here. Give me 1 second. All right, so the section 1-1, as we've seen a moment ago, and I'm hoping you got your books open and you're reading along with me on this. Section 1-1 is we're going to talk about what do we mean by descriptive and inferential statistics. All right, so the first thing we always do in a math class is we got to have definitions. Okay, so to get knowledge about these, what he's calling haphazard situations, in other words, just kind of random events. He's kind of like, well, haphazard. Look. Okay, statisticians will collect information for what's called a variable. Okay, a variable is a characteristic or it's an attribute, and it can assume different values. So the characteristic might be you're measuring the heights of or weights of fifth graders. That's the variable. The variable is the height. The variable is the weight. The variable of college students might be grade point average. Variable might be, how old are you? That sort of thing. That's the variable. The data are the actual values. Those are the measurements that you make. So you got to be clear, make sure you make that distinction. A variable is the actual characteristic itself, whereas the data are the actual measurements. Okay. Now, variables whose values are determined by chance, we call them a random variable. Now that seems kind of weird, doesn't it? I mean, it's like, why do we call it a random variable? Why is it by chance? I mean, if I measure your height, that's not by chance. It's there. That's what it is, okay? It is what it is. I hate that expression. And just to go on a side note, I do this all the time. I hope you don't mind. I go off on side notes because this is community college. Is the first 2 years of university, right? So you should be used to, or you should be willing to learn outside of a narrow field. When you say something like, it is what it is, that's what's called a tautology. A tautology is just an expression that really is true, but it's almost meaningless. Okay, so a tautology, if you go to Google and you type in define and then the word, it'll give you a definition, okay? So it's a saying of the same thing twice. So it is what it is. Well, you're just saying the same thing twice, right? Okay, it's not considered exactly proper, okay? What's an example of a tautology? It was adequate enough. That's a tautology because you're saying the same thing twice. If it's adequate, then obviously it's enough, okay? It conveys the same meaning. So a lot of times, people will say things that they think are saying something significant, but they're really not. Like, it is what it is doesn't mean a thing, right? Because it's just saying the same thing twice. All right, so if you have Uh, this is our first real definition. I'm urging you, be careful with definitions. They're very important. So my time is almost up. I'm going to end this video right now. This is video number 1.